Welcome to Chapter 2A. In this segment, we'll walk through how to set up your processing parameters using templates and custom settings, so your HDX data is ready for analysis. Let's begin.
All right, it's time to process our data. To bring up the processing window that we had before, just click on the process menu and click the process button. This will pop up the window that we saw before, which you will see there are two processing options for this project, which would be the HDX DIA and the conventional HDX MS1. Again, if you have DIA data, use the DIA method, but you can use conventional MS1 analysis as well. The parameters are going to be listed on the right-hand side of the processing window. But before I get to them, I'd like to also introduce the recent parameters section and the saved parameters section. Any previous data processing you've done will appear here as recent parameters so that you can always select the last set of parameters that you are using. It only will keep the last 5. There's also a section here where you can store parameter templates. For example, if I have set some parameters that I want to save for later and never have to set them manually again, I can just name them here. And these parameters will be stored so that they will always be available anytime I want to process a new project. You can do this for, say, if you have different types of instruments with different resolutions, or if you change your chromatography, or if you have a specific way of processing individual projects that require different parameters. Parameters once set can be exported and saved to your disk, and they can also be imported if you have a set of processing parameters, and these files can be shared around as well with the projects. Okay, so the parameters section, the most important parameters that you should set for your DIA method would be the tolerance. This is your mass tolerance. So if your instrument is calibrated, then it would be the relative resolution of your instrument that would be measured in ppm or in Thomson, depending on the actual resolution. And this can be set for the MS1 level, but also for the MS2, MSMS level. So set this to your instruments. These parameters are default for Tribrid instruments from Thermo, but if you have different instruments, just adjust these to your type of instrument. The peptide elution time is the next important parameter that needs to be set. This is going to be custom. Some people like very short gradients, others do longer gradients. So the important thing here is to set the value of your of the width of your peak. So for example, this represents 0.15 minutes, and that should be from base to base of an LC peak. As well, chromatography isn't always perfectly reproducible. There's always going to be a little bit of shifting between different replicates, between different time points. So it's good to set a tolerance here for the amount of variance that you can expect in your data. The larger this value you set, the more likely the algorithm will spend a lot of time searching for peptides in regions where they may not exist. So it's good to just set this to only cover the variance that you would expect for a peptide to have versus its original retention time in the mapping files. The rest of the parameters can be kept default. There are some DIA specific parameters that you can set. If you're using TOFs, you can set a minimum absolute intensity. Orbitraps typically don't need this just because they do a little bit of signal processing themselves. But you can set a minimum intensity. You can set how many fragments you'd expect a peptide to have minimally in the DIA data so that it can be so that you can calculate its duration from MS2. But these values can be changed later as well. So I'm going to leave them default. Before I move on, I'll just draw your attention a little bit. There's an advanced parameter setting that will uncover a lot more parameters that are modifiable. I will skip this for now and cover this in a later video, but this allows pretty tailored customization of the parameters to your specific type of data. Once your parameters are set, just click the process button and this will start the processing of the project. Once the data processing is started, you will see a progress bar that goes from 0 to 100%, that tracks the progress of the whole project. That is all of the data files with all of the peptides. They will be searched one by one. Once everything finishes, it'll have a little bit of a post-processing event at the end, which will then crunch all of the data that it got from all the files to make some decisions. You can expect around 1 to 5 minutes per file for, let's say, about 1,000 peptides. So that would be 1 to 5 minutes for Orbitrap data per file. So even large projects can last anywhere between 15 minutes to a couple hours, depending on the scale of your project, how many time points, how many replicates you have, and as well as how many peptides you have. Once this progress bar finishes, you will see a result will be added under the results section, and a bunch of views will appear in the middle of the screen.
Now that your data is processed, it's time to explore the results. In Chapter 2B, we'll show you how to review your processed project and evaluate the key outputs. See you there.